Hey, this is Math Minutes Pro with Dr. Harrison. Today, we will talk about how to use basic right triangle trigonometry to find the missing side of a right triangle. So let's first begin by stating three basic trigonometric ratios that we're going to talk about. That's sine, cosine, and tangent. So let me give some notes over here on the left side. So here we have sine, all right, also abbreviated as SIN. And I'm going to put some notes here and it'll make more sense. I'm going to use a strategy of Soh, and I'm going to write the three basic trigonometric ratios. So for sine, it's opposite over hypotenuse, okay? Then we have cosine, okay? Abbreviated as COS. We're going to use a strategy of Cah. I'll explain that later. And that's adjacent over hypotenuse. So I'm just going to underline these two letters here for opposite over hypotenuse and adjacent over hypotenuse, A and H, okay? And then we'll go to tangent. Abbreviated Toa, or the strategy we're going to use, and that's also written as tan. So the trigonometric ratio for this is opposite over adjacent, opposite over adjacent. So I'm going to call these here three trig ratios. All right, these are the three basic trigonometric ratios you have here: sine, cosine, and tangent. Now let's see if we can have this make more sense and list the key parts of a right triangle. So here we have a right triangle here. It's right because we put the box there. That box represents 90 degrees. And we always identify theta, Theta. I'll spell that out. That's referring to that Greek symbol. And now theta could be here in this angle, or it could be here in this angle. If theta is here, then we would call this side opposite, and we would call this side right here is always the hypotenuse. I'll abbreviate it. Well, I'll go ahead and spell it out. All right, so this side is the hypotenuse. The hypotenuse is always opposite the 90-degree angle. If we let this be theta, then this side is opposite of theta, okay? And then this side right here, which is next to theta, is called adjacent. All right? This is a key skill in knowing how to label a right triangle when you identify theta, okay? So I'm going to erase this triangle again, and then I'm going to show you how we label the right triangle when theta is up here. So let me go ahead and erase this triangle. Let's get the right triangle sketched again. There's our 90-degree angle. Instead of theta being here, I'm going to put theta here, okay? Write that again, theta, referring to this Greek symbol, which is which means degree, like 60 degrees or something like that. So remember, this side, which is opposite of the 90-degree angle, is always the hypotenuse. Okay? Now, if this is theta, then this side is opposite theta. So this is your opposite. And this has to be the adjacent. All right. So these terms are coming from here. Notice we have O and H for opposite over hypotenuse. Okay. We also have A and H for adjacent over hypotenuse. We have O and A for opposite over adjacent. So I'm going to leave this right here, and I'm going to go ahead and we'll move forward in beginning to solve our problem. So let me go ahead and separate this a bit. All right, so let's go ahead and get started. So if you are given, usually when you're solving a right triangle trigonometry problem and you're asked to find the length of a side, usually you're given theta and the length of one side, and you have to calculate the other side. So here's the problem here. I'll go ahead and sketch the right triangle. Very good. And this is our theta, and that is equal to 39 degrees, okay? Sometimes they'll write 39 degrees in there, but I'm just saying that that's our theta, okay? And let's say the length of this, let's go ahead and put our right triangle up. The length of that hypotenuse is 7. And we need to find the length of this side represented as x. So I'm going to show you how to use this information over here. All right, we're going to go through the steps. All right. So first thing we want to be clear on is identifying what theta is. And we know what theta is. It's 39 degrees. Now that we know that, we can label parts of the triangle, because based on how we label it, that's going to tell us which of these three trigonometric ratios we have to use to calculate the length of x. So let's go ahead and label. If this is theta, this is opposite, but they didn't give us that length, so we don't need to label that. Now we know this is the hypotenuse, 7, because that's opposite the right angle. So I'll just draw a line here and label that. That's our hypotenuse. All right. And if this is theta, this is the side next to theta. Adjacent means next to. So this is adjacent. All right. Now, look over here and see you have sine, cosine, and tangent. We're given a hypotenuse, the length of the hypotenuse, and x for the adjacent. So which trig ratio has both the hypotenuse and adjacent? Well, it's not sine, that's O and H. We need A and H, okay? So let me just abbreviate that as we need A and we need H. So it's not sine. Let's go to tangent. That's O and A for opposite over adjacent. They did not give us opposite, so we're not going to use tangent. The only one left is cosine, which is adjacent and hypotenuse. Well, they're giving us adjacent and hypotenuse. So this is a very important step. You now move from labeling the picture to writing the trigonometric equation. So we're going to find the length of x. So we have cosine That's the one we're going with here. Cosine of 39 degrees is equal to, it says, adjacent over hypotenuse. The length of the adjacent side is x, and the hypotenuse is 7. All right. So if you've written this equation, you're about halfway there. All right, because if you write the equation incorrectly, even if you solve it correctly, you're not going to get the correct length of this side x. Now, I'm going to use something referred to as fraction buster, because to get x by itself, I have to get rid of the 7. So I'm going to multiply both sides of this equation by 7. So first I'm going to write this equation again. Cosine 39 degrees equals x over 7. And I'm going to multiply both sides. I need a little space, so let me bring this over here a little bit. I'm going to multiply this side of the equation by 7. And multiply this side of the equation by 7. All right, notice, when I multiply this side on the right side by 7, the 7's cross out. So I'll just do that to let you know that 7 divided by 7 is 1. So when we write this again, we end up with 7 times the cosine of 39 degrees equals x. All right? Very good. So I need a little space. I'm going to bring this over here and rewrite it. 7 times the cosine 39 degrees, put that degree symbol there, equals x. So now we move to the calculator. Okay? Now, depending on what type of calculator you have, that will determine how you enter this in, okay? Some calculators you can literally enter in 7 times cosine 39, and then it will give you the value. For other calculators, you'll have to enter in cosine 39. You'll hit enter, and then get a value, and then multiply that by 7. For the calculator I have, we're going to first enter in, I'm going to press cosine, okay? And I'll put this here. I don't know if it will show, but I'm going to, with the video, but I'm going to put it here anyway. So I had a cosine 39, then I'm going to hit enter. That gives me 0.77145961. That's the cosine of 39 degrees, but remember, I have to multiply it by 7. So I hit times 7, and then I get an answer, 5.44002173. So we're just going to round that, okay? And we're going to round it to 5.44 equals x. And this is our final answer, okay? Very good. So this looks like a reasonable answer, because if the hypotenuse is 7, think about what you know about Pythagorean theorem. You can have a 3, 4, 5 triangle. So if this is 7, this length could not be 90 meters, right? So 5.44 is a reasonable number, all right? So that's our answer. So how did we solve this problem again? First, I would recommend that you memorize Soh Cah Toa. If you memorize Soh Cah Toa, you'll automatically know that sine means opposite over adjacent for Soh. Ka means adjacent over hypotenuse for Ka. Toa means opposite over adjacent for tangent, okay? So if you commit Soh Cah Toa to memory, you'll automatically know how to write the trigonometric ratio. All right, so what did we do? We identified theta. Then we found that we reasoned that this is our hypotenuse, the length of 7, has a length of 7, opposite the right angle. And this side is the adjacent to theta, so we said here we have hypotenuse and adjacent, so we had to use the cosine here. So we write the equation as cosine of 39 degrees equals Cah adjacent, which is x, over hypotenuse, which is 7. Then we go to our basic algebra or pre-algebra skills. Solving for x, we have to get rid of this 7 to isolate that variable x. So we multiplied both sides of this equation by 7. Then we ended up with 7 times the cosine 39 degrees equals x. And then for my calculator, I entered cosine of 39 degrees. I got a number. Then I pressed multiply times 7. And then I had x equals 5.44. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page in my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.